Okay, so we are going to solve quadratics by factoring. Now, you've solved quadratics by graphing, and one of the things that you looked for with graphing were the x-intercepts. And what we know about x-intercepts is that the y equals 0. And by finding those x-intercepts, setting y equal to 0, we're finding what's called the roots of our quadratic, and those roots will be our solutions. With graphing, it was could be pretty easy to see because you're, like I said, looking for the x-intercepts. Now with factoring, you would want to use factoring when either it's your preferred method or it's not something that seems easy to graph, or you don't have graph paper or whatever. So this is just another method of solving quadratics. So through these lessons, you'll pick up multiple strategies for doing the same exact thing. Okay, so this is no different than solving by graphing. It's just a different method. All right, so first thing we're going to do is we're just going to go ahead and write down some steps. Now it does say we're solving by factoring, so of course our steps are going to include that. But step one, just like with some different things that we've done over these lessons, to find our x-intercepts, you make something equal to 0, right? You make the y equal to 0. So what we're going to do is we're going to start by making our equation equal to 0. Oops. So set the quadratic equation equal to 0. Okay, so that's the first step. Set the quadratic equation equal to 0. Step 2, factor the quadratic expression. Okay. Step 3, set each factor equal to 0. Then solve for x. Okay, so those are our 3 steps. So let's get into an example. So we're going to solve x squared minus 10x plus 49 equals 4x plus 1. So this is not going to be as simple as just saying if it was x squared minus 10x plus 49 equals y, we just make the y 0. It doesn't work like that. We actually need to do some solving so that one side becomes 0 and then everything else is on the other. So that means that I need to take this expression and get it over to the left-hand side. I need to eliminate it from the right. So using our equation solving process, we would subtract a 4x from each side. And now eventually we're going to subtract a 1 also because I need this side to become 0. So we can do that in one step. So we get x squared minus 14x plus 48 equals 0. Okay, so this is step 1. Step 2 says, scroll up here, factor the quadratic expression. So now we're going to factor this expression. So remember, we have our a is 1, our b is negative 14, and our c is 48. So we need our numbers to add up to 14 and multiply to become a times c, right? Or 48. So we need to think of factors of 48 that add up to 14. And we're going to get 6 and 8, but I need them to add up to 14, so it would be -6, -8. So my factored form is going to be x minus 6 times x minus 8 equals 0. That's step 2. And then step 3, set each factor equal to 0, then solve for x. So x minus 6 equals 0, and x minus 8 equals 0. X equals 6, and x equals 8. Now remember, there were multiple processes that you could go through to factor. So as for work being shown, because there's been a few times where work is not getting shown, so just a little bit of a side note, this would be acceptable work, okay? Another option that you could have for work would be, let's say that you don't need to do the symbols or extra things like that off to the side. You could see that -14x had to be broken down into -6x and -8x. You could have done this. You could have rewritten the expression and split up that -14x into the two factors, writing them as terms. And then from there, it shows, then I could see that it would be x minus 6 and x minus 8. Okay, I would be able to see that that was your thought process. Because remember, the work is just so that you can get your thought process on paper. And then, of course, the other option that you have is the area model. So if you did this, that would be acceptable work also. So that's okay work, this is okay work. And then, of course, the work that I have here is definitely expected. But to get from the quadratic equaling 0 to your factored state, I need to see some sort of work done. It's important to help you practice the process. Okay, example 2. Solve 4x squared minus 8x minus 5 equals 0. Okay, so we've got a much simpler version here. Step 1 has already been done for us, so step 2 is to factor. Right? Now, I'm going to show you another process for factoring. Once you figure out how to split this middle section up, and now a situation like this is when it's very important that you did the work, okay, like on number 1. Because doing the work on number 1 when it's simple, because you could be telling yourself, well, I just can see how to split up -14x in that last one. Here, it's a little bit more difficult because our a does not equal 1. Okay, so our a is 4, our b is -8, and c is -5. Now, this little pattern puzzle thing here is good to do no matter what. Right, so it needs to add up to 8 and multiply to make 20. So -10, +2 would be our two factors. Now the thing is, this doesn't just become x minus 10 and x plus 2. That is not what happens. If you were to FOIL that out, you would realize it does not equal that expression. So that's where it's very important that you take your time on these kind of questions. So what's going to happen here, I'm going to suggest that you do the grouping method. Let me get this out of the way, and you'll see why here in a second. So I have 4x squared. Now for the grouping method, we're going to split up the negative 8x and rewrite it as negative 10x plus 2x minus 5. And then what we're going to do is we're going to group these two together, and we're going to divide out the common factor. And when we divide out a factor, we need to end up having the same expression in the parentheses. Okay, so for example, for 4x squared and 10x, I have a 2x that they both have in common. And if I divide out a 2x, I'm left with 2x minus 5. And if you notice here, I have 2x minus 5. So that I have a number out in the front, I would just write a 1. So that makes 2x minus 5 the common factor. Now, if you are struggling with this portion, you're going to want to go back and watch the lessons for factoring quadratics, and that should bring this kind of back to memory. But basically what's happening here is these are common factors. Okay, just like up here, I could divide out a 2x because that's what each term had in common. Well, in this case, the 2x minus 5 is a term that they have in common. So it's kind of like I'm pulling that out, and what I'm left with is 2x plus 1. And that's my factored quadratic. And then step 3, I'm going to solve for x. So that means I have 2x minus 5 equals 0, 2x plus 1 equals 0. So I get x equals 5 halves, and x equals negative 1 half. Oops. You could also write those as decimals. Now, another way that you can write your answer would be as a list as well. All right. So now from this point forward, you can choose when you're factoring. You can factor by grouping. I will tell you that the grouping, for the most part, will work every time. If the expression is able to be factored, the grouping should be pretty consistent, and you can count on factoring working. The others, sometimes it may not be as easy. Okay, so x squared minus 8x equals negative 16. So step 1, we're going to make this equal to 0. Then we're going to factor. So go ahead and do this with me. So for my factors, it would be negative 4, negative 4. And then I only need to set 1 equal to 0 because I would get the same value of x if I did them both. So it's redundant and not necessary. So my solution is x equals 4. And what that means, because you might be thinking, oh, well, I should have 2. That just means that my parabola is on the x-axis if you were to graph it. Now, I'm not saying that's what it looks like. I just sketched it. But whenever you have one solution, that means that the vertex is on the x-axis. Okay, let's look at another one. Solve 6x squared minus 12x equals 0. So it's already set equal to 0. Now we just need to factor. Now, one of the things that's important is that you stop before you just start going into like robot mode and factoring. Stop and look and see what the quadratic expression looks like before you determine kind of your plan of action. Because if we look here, my A is 6, my B is negative 12, and my C is 0. I don't have a C. So that's the first clue that maybe there's something special going on, or maybe there's isn't as much that we have to really do. Because if you look here, if I look at these two terms, they both have a 6x that I can divide out. So now at this point, we just follow the process. Once you factor it, then we figure out what x can equal. And so in this case, I'm going to see, because remember that the property that says if either of these terms or either of these factors are equal to 0, then the whole equation is equal to 0, right? So 6x equals 0, x minus 2 equals 0. You can get x equals 0. That is a possible solution. Because if you think about it, I can have an x-intercept at the origin. That's what that means. So example 5, 9x squared minus 49 equals 0. So this is difference of squares. And the reason I know that, because 9 is a perfect square and 49 is a perfect square. So this is something where you should remember the pattern, hopefully. And what you find is we square root each of these terms. And those become the terms in my factored form. One expression will be addition, one will be subtraction. And then I set each equal to 0. So I get x equals negative 7/3, positive 7/3. Now another option, so let me make sure you can see that's a 7. Another option for this is actually to use square roots. Okay, so this option is to use square roots. So here's how you would do that. 9x squared minus 49 equals 0. And what I'm going to do is I'm actually going to, even though the first step was to set this equal to 0, because I see that each of these are perfect squares, I'm actually going to, get each term on the other side. So I'm going to solve for the, to get the x's on one side. Because then what I can do is I can take the square root of each side. And the square root of 9x squared is 3x. The square root of 49 is positive negative 7. Now, normally if you don't see the positive or negative, it's just positive. But in this case, we are square rooting both sides. So when you take the square root, when you're solving like this, we are hoping to get two different x values, right? Because that shows where our parabola has x-intercepts. So then I solve and I get x equals positive or negative 7/3, which is the same thing that I got up above. They're just written separately up above. And that's it.